Okay, welcome back. Today we're going to be looking into some exercises on prime numbers. So let's just get started with question 1. Express the following numbers as the product of prime factors. Question A, 30. So the product of prime factors, you can write it as 2 times 3 times 5, right? So 2 and 3 and 5 are all prime factors. We're just going to multiply them together. You're going to get 30. Question B, 24. The answer would be 2 times 2 times 3. Question C is 100. The product of prime factors is 2 times 2 times 5 times 5. And question D is 1125. The product of prime factors is 3 times 3 times 5 times 5 times 5. So, if you are unsure how you get these answers, I'm going to give you 2 examples using question C and question D. Question C, we're going to use the long division method because that's my preferred method. Do not forget that you have also the tree diagram method which you can use and you will get the same answer. So using the long division method, I'm going to use 100, divide by 2, I get 50, divide by 2 again, I get 25, right? 25 cannot be divided by 2, so the next best prime number that I can use would be 5. So 25 divided by 5, I get 5, and 5 divided by 5, I get 1. So once I reach 1, I'm going to stop, and I'm going to take all the numbers on the left side here and multiply them together. So those are the products of prime factors that will give you 100 if you calculate them out. Okay, so for question D, it will be the same thing. I'm also using long division. I'm going to get 1125 divided by 3, 375 divided by 3, 125 divided by 5, 25 divided by 5, 5 divided by 5 until I get 1. And then I stop there, take all the numbers on the left side, put them in a product. And that's about it. Question 1 is done. Okay, moving on to question 2. Which of the following numbers are prime? Your options are 13, 45, 57, 39, 87, 89, and 11. There are only 3 answers to this question. The first one is 13, and then 89, and then 11. To show how the remaining numbers are not prime, you can show in a way that divides by another number that is not 1 and itself, right? So all numbers here can be divided by 1 and itself. But if let's say 45, it can also be divided by 5. So that is like one of the proof that you can show whether that it is a prime or not. Okay, 57 you can divide by 3, you get 19. 39 you can divide by 3, you get 13. And 87 you can divide by 3 to get 29. So all of these numbers not only can be divided by 1 and itself, it can also be divided by another integer. So that's what proves that they are not prime numbers. Okay, so the new thing here that you're going to learn today is using prime numbers to find HCF and LCM. Right? We're going to do this by expressing 2 or more numbers as a product of prime factors. And so if that doesn't make sense, we're just going to look at an example. Find the HCF of 168 and 180. So I'm going to use the long division method again, but this time I'm going to use for both numbers. I'm going to do it together for 168 and 180, and I'm going to find the common prime factors. So between 168 and 180, they both can be divided by 2. So I'm going to write 2 and divide both numbers by 2. So 168 divided by 2 is 84. 180 divided by 2 is 90. Again, I'm going to divide both by 2 again because it's possible. 84 divided by 2, I get 42. 90 divided by 2, I get 45. Okay, so the next pair of numbers, 42 and 45, 42 can be divided by 2, but 45 cannot. So in this case, you want to skip number 2, and you want to go to the next best prime number that can divide both numbers, which is 3. So 42 divided by 3 is 14. 45 divided by 3, you get 15. Okay, now when you reach to this pair of numbers, 14 and 15, you realize that there is no common numbers that can divide both of them. There's no common prime numbers, most importantly. And in this case, when you reach to this situation, you're just gonna stop, right? No more common prime factors, just stop. Okay, on the left side here are all the common prime factors that we have gotten from our long division just now. And all I'm going to do is I'm going to take those numbers and multiply them together. This will give me my HCF. Okay, what does that mean is that now, if I take 168 divided by 12, it is completely divisible and it will return me 14. If I take 180 divided by 12, it is also completely divisible and it will return me 15. So in this case, 12 is the common factor between 168 and 180. And in this case also, using this method, you find that this is the highest common factor between both numbers. Okay, so this is the example you can use, or this is the example method that you can always apply to find your HCF, no matter how big of a number you get, right? This is foolproof. This is a foolproof method that you can always use. But then something sweet to add on, which is that you can also use a very similar method to find your LCM. Okay, and we're going to use the same example again. Find the LCM of 168 and 180. And all you're going to do is you're going to take all the numbers on the left side and as well as the bottom pair numbers, which is 14 and 15, right? The way you're going to write it is your LCM is equals to 2 times 2 times 3 times 14 times 15. What you're going to get, you're going to get an answer of 2,520. So what that means is that if you take 168 times 15, you get 2,520. 180 times 14 is 2,520. So 2,520 here is the common multiple between those two numbers, right? When you get really big numbers, usually the common multiple is also going to be quite big, right? But here, using this method, you're going to find the lowest common multiple between the two numbers. And again, no matter how big of a number you get, if you apply this method, you are sure to find the answer. Okay, so that is it for today's video. In the next video, we're still going to be looking at exercises of HCF and LCM, and maybe we just do a few more questions until we continue to the next topic. Okay, for any inquiries, you can put them in the comments below or you can check the description, and I'll see you in the next video.